19dB10b. A small ray drop of mass m is released from rest from a rain cloud and falls to earth under its own weight. It is subject to air resistance kmv. kmv. Okay, so it's not per mass. That's the total air resistance, where v is the speed of the raindrop after t seconds and k is a positive constant. Express v in terms of g, k, and t, noting the following. Okay, let's figure out what's going on. Raindrop, red raindrop going down, positive acceleration mg, and a upwards force of kmv opposing it. It's some hard to know whether, so overall it's falling downwards. So downwards, you do it two ways, I suppose, but the way I'm inclined to do it this time is I'm going to do a or force equals mg minus kmv. That's the way I'd like to do it, and that in turn will show me that ma also stands in line with g minus kv, which is what I need later on. So I'm pretty happy about that. So that's part of the reason why I'm putting the g as positive and the kv as negative. And then ma equals mg minus mkv, and then a in turn is going to be g minus kv. Now express v in terms of t, so there's no distance there, so we're going to change a with the v dt. So now we're going to change a here with the v dt. Okay, now let's start off with some things here. Now, what do we know? It's released from rest, so v equals 0 when t equals 0. And what else do we know is that v is the speed of the raindrop after t, so v equals v when t equals t. So we got limits there to work with, which is great. So what we're going to do is go and cross multiply this down. So I'm going to have 1 over g minus kv equals dt. Just lumping all this together, cross multiplying it out down, leaving the number 1. And then I'm going to put in my limits. It's just 1, 0, and t. And then we're going to put in 0 and v. Next is going to tell me how to integrate this, which is quite kind of them. Okay, so we put this in here, like so. We learn how to use that. So what it wants me to use is minus 1 over k ln g minus kv, no bother, and that is from v to 0, and that will equal t from t to 0. Much quicker than what those guys are planning. Now I'm going to lob in my v and my 0, so it's going to be minus 1 over k ln g minus kv, and then double minus because it's going to be minus times a minus, which would be plus 1 over k ln g minus kv, but it's going to be k times 0, which eliminates the kv part, so it's just going to be g, and that equals t. Now I'm probably going to factorize out some bits here. I'm going to do, it's going to be 1 over k. It's going to be 1 over k ln g minus ln g minus kv. And what it wants is, it wants phi on its own. Okay, so that's where the issue is going to be. It wants phi on its own. So I'm going to use remember the division rule of logs, where you take log 5, take away log 4 would be log 5 over 4. You can put in those brackets if you want. So I'm going to have 1 over, I'm going to bring that k up to get rid of it for a second. So this k is division on the right, which will make it multiplication on the left. So I'm just going to cheekily get rid of that k there. Okay, so that'll end up there in a second. Okay, so it's going to be kt on the right, and then on the left it's going to be ln g divided by G over KV. Now remember the trick with ln. ln means log base e. So if log 5 base e was equal to x, this means 5 equals e to the power of x. And we're going to use the same trick here. Okay, so it's going to be G over G minus KV is going to be equal to e comes up, and it's going to be e to the power of KT. Nearly in business now. Then we're going to get G equals G. Going to multiply this out. G e KT minus KV e to the KT. Now I'm going to bring the KV to the left, so it's going to be KV e to the power KT equals G e to the power KT minus G. Going to isolate out the V there, so it's going to be V equals G e to the KT minus G all over K e to the KT. You could also thin this out if you want. You could say it's G over K on the outside, and then you could say it's e to the KT minus 1 over e to the KT on the inside here. And some people might in turn break that down into G over K into, you can break this into two parts. You can say it's e to the KT over e to the KT and minus 1 over e to the KT, which is 1 minus e to the power minus KT. That also works. So it's any of those answers are acceptable. Like that's acceptable, that's acceptable, that's acceptable. I suppose the last one is the nicest. It's thinned out a lot better than the other ones. Okay, so that's your answer right there. Now let's go to the last one. The speed at which the raindrop falls increases until it reaches a maximum speed. This is called terminal velocity V. Find the time it takes for the raindrop to reach a speed of V over 2. Well, terminal velocity is an interesting concept. Terminal velocity basically means as t approaches infinity. Okay, so we got to figure out what's going to happen to these variables here as t gets bigger and bigger and bigger. Well, let's have a look at an exponential curve. Okay, so I'll give you an example. Let's have a look at let's say f of x mode setup. Let's have a look at f of x equals, I don't know, alpha, where is e? Alpha e, sorry, e, not alpha, shift e to the minus, I don't know, x, okay, or 5x even, okay, whatever you want, where 5 represents k and x represents t. Now look what happens when t gets bigger. Okay, we're going to end at, I don't know, 200. And we're going to go up in steps of 10, I suppose, okay? And look what happens to the number. It starts off at 1, and then it gets smaller and smaller and smaller until it eventually turns into 0. So, as t approaches infinity, your velocity is going to be g over k into 1 minus 0. Your terminal velocity is actually just going to be g over k. Alrighty. So you're looking for the time taken for it to reach. You're looking for the time taken for it to reach a velocity of v over 2. So v over 2, or terminal velocity over 2, will be g over 2k. Now we can go back up here to some of our workings. Remember when we had t on its own over here? Okay, and what we were using was 0 and v. Well, we're not going to use v anymore. Okay, so v, we're going to sub out v in a second. Okay, so I'm actually going to stop us around here. Okay, so I'm going to stop us at this part of the equation. And what we know about this is that v actually equals g over 2k. So this is going to be interesting for us to see how this works. G over 2k. So we have kt on the left, and so it's going to be ln g minus g times k over g over 2k. Now this could work reasonably well. V equals g over 2k, and that equals kt. Okay. Now, if we look at our question, what does it want? Find the time it takes for the raindrop to reach speed v over 2. Okay, so where was it? It was here. So what I'd be doing here is I'd be having a look at this now, and I'd be saying, okay, this is ln, this is still g on top, but this is on the bottom, it's actually g minus g over 2, because the k's cancel. So g minus a half g is g over 2, and then g divided by a half g is 2. So this is actually ln2 equals kt, and this means your time to reach half its terminal velocity is ln2 over k, and that's much quicker than the other way of doing it.